A new rate, right angle triangles, big time. Once upon a time, there was a man by the name of Pythagorean Theorem. So Mr. Theorem was all saying, hey, I gotta find me the length of this thing, and I only know this and this. And that's the end of the story. So that's where the problem starts. Where was I going with this? We need to know some basic vocabulary when it comes to this. Okay, so number one, we have the right angle triangle.
A new rate?
Boom. We put that little nub down there so that we understand that this means it's a right angle triangle. First, the right equals 90 degrees, right? 90 degrees is what I'm talking about.
A new rate?
Squares. We talk about squares in two ways. Number one, square. How do you like that? Square. Shoot, we could even put that little square there, meaning that it is a square. It's the bottom corner of a square. A square means that all of these sides, its four sides, are what are called congruent. You didn't know that, did you? All sides are equal. Meaning, let's say this side is 2. That means all four of these sides are 2. If we want to find the area, then that would be 2 times 2, or base times width. Or in exponent land, we could easily just call it 2 squared. Now, most of the time, we use little letters like x. So we would change this to x squared, and that will equal the area. Right?
A new rate?
And if we want to get rid of this squared, x would be one of the sides. I think that's where a lot of the confusion happens, right?
A new rate?
We got this right angle triangle, and we need to Invisalign this sucker. Mr. Theorem had it right. If we had the length of this side, and we can call it whatever you want. Some people call this A, and some people call this B, and some people call this C. You can go X, Y, Z, whatever letters you want. I did the mistake of mistakes. You could use letters if you want. I don't care. Right?
A new rate?
This is what we call a leg of the right angle triangle. This is another leg of the right angle triangle. And this magical thing is called the hypotenuse, right? The longest side of the right angle triangle. This little square, it basically touches the legs. Saucy, I know, but it is what it is. If you're looking for the legs, leg, longest side, hypotenuse. Mr. Theorem said this, that if we had the length of this one leg, we could find the square, or if we found the area of this leg. Remember, these sides are all congruent. And if we were going to do the area of this thing, this would be leg squared. Okay? Same thing, if we found the area of this, the square that this leg makes, I don't even know if that's square, but it's going to be, right?
A new rate?
We could find the area, and remember these sides are all congruent. Just see what I'm doing here? If we added these together, these areas, this area of this leg and the area of this leg, would equal, look at what I've gone done did. Unprofessional, right?
A new rate?
If we added these together, they equal the area of the square that the hypotenuse makes. In fact, I could even just go ahead and say, and that's his whole theorem, right? This is his whole idea. Meaning that if we could get the area of this square, then we would simply need to square root this homeboy to get rid of this square, and we would be left with the length of this side of the unknown. And so if we were going to do this, well, let's do it right. Let's go through an example. I'll show you one. Check this out. I'm going to get serious, guys. I'm going to get so serious that you don't even know, right?
A new right?
Behold, theorem's formula. The area, remember this means area, the area of the hypotenuse squared, right, equals the leg squared plus the leg squared. Now, of course, you probably have been taught c squared equals a squared plus b squared. That's no problem. Use it, I don't care. It's what works for you, right? So we have these two squares. The length of this right angle triangle, first things first, identifying that it's a right angle triangle, which it is because we have this little thing going on here. This is pointing to the legs, 3 and 4. So if we kind of look, the area, so this is like a 3 by 3 box, right? See what I'm saying? So the square would be 3 times 3, which is 9. The area of this box is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9 squares. Just so you can see it.
Right? Right?
We have 4 squares by 4 squares. Isn't that great? So 4 times 4, the area is 16. Right? If we were to add these together, so we have 9, oh, let's get real. Let's get real. Plus 16. And this will equal 25. So 25 squares are here. And it's a square, which means all the sides have to be congruent. The way to figure this out is to square root this. If we square root this, we will be given the length of the hypotenuse. Punch that into your calculator. We have 5. So the hypotenuse here is 5, right?
A new right?
Okay, I'm pretty proud of that. It's a pretty good box, right? 5 by 5. If we were to count this up, 5 by 5 is 25, which equals 9 plus 16. Now, there is no way that you would be expected to be drawing all these grids, but that's the basics of it. That's so you can see what's happening. And there's different ways. Here, hold on, check this out. Movie magic, right?
A new right?
Right angle triangle. Let's say we had, I don't know, we didn't know what this leg was. And of course, remember, you can label it any variable you want. X, Y, A, B, C, doesn't matter. And let's say we had, I don't know, 10 for this guy and 8 for this guy. If you're looking for a hypotenuse, use this formula. If you're looking for a leg, though, consistency, right? If we have this right angle triangle, the combination of this leg squared and that leg squared, or the area of this square and the area of that squared equals the area of this squared. If we have that then we just need to take away the area of one leg to find the other. It's simple arithmetic. So let's do this real quick. If this is what it is, 10 squared minus 8 squared like any mathematical principle, what you need now is practice, right? I know, right?
A new right?
I know, right? Right angle triangles, Mr. Theorem knew it all. Practice this hard.
A new right?